Good afternoon. A warm welcome to our guest speaker, Dr. Tewari, and all participants for today's session on hydrogen spiked natural gas. Would like to inform all participants that all mics and cameras have been disabled. Please type in your questions in chat box. Session will be followed by question and answers. And please reach out to at email for any clarifications or so. And we are available on mobile and WhatsApp. I would request our program director, Dr. Patra, to introduce our speaker and the subject. Over to Dr. Patra.
Thanks, Manju. Good afternoon, my dear friends, participants of this webinar. This is yet one more discussion session, guest speaking session that we are participating today. And today's subject is very interesting. We have an expert on the subject, Dr. Anand Tewari. He in the industry perhaps needs no introduction. Suffice to say that he superannuated from Indian Oil Corporation as Executive Director Planning. His PhD in corrosion from University of Petroleum and Energy Studies, and he is an expert in many expert commissions, committees, bodies, etc., etc. Just to reflect on the subject, that friends, we all know that hydrogen is a decentralized, renewable energy. Notwithstanding that, at times hydrogen needs to be transported from one place to another. It is not always that the production of hydrogen can coexist with the consumption of hydrogen. Though currently it is operating on that principle, that it is being consumed wherever it is being produced, and there is a concept of cluster of consumption units so that hydrogen did not be transported for longer distance. But the need for hydrogen transportation is unavoidable in certain cases. One, when you are going to distribute hydrogen to multiple consumption units, say for example a CGD, city gas distribution unit, then you need a pipeline transportation of hydrogen. Secondly, if hydrogen has to be traded amongst countries and between countries, then again this needs to be transported. So the summary statement is the development of hydrogen economy depends upon adequate transportation infrastructure of hydrogen. And then next point is this transportation infrastructure needs to be integrated with other energy transport infrastructure. The question is why? What is so problem with having an independent transportation infrastructure for hydrogen? In the literature, 4 reasons have been cited. 1, technological uncertainty as of today. 2, unpredictability of future demand and supply of hydrogen. 3, network externality effect. And 4th, investment irreversibility of grid-based hydrogen. And what we find in the literature, there is a concept of polygrid of hydrogen, and that is said to be the backbone of decarbonized energy system by 2050. Now, this poly-grid network of energy infrastructure is a combination of 4 types of hydrogen transport infrastructure. One is repurposed gas network. Second is power network, supplying power to hydrogen facilities. Third is conventional transport like rail, road, pipeline, and marine transportation network. And then the fourth is dedicated infrastructure for hydrogen transportation. However, these are some of the broad concepts. The real subject will be presented by Dr. Tewari. Just I'll conclude my introduction by saying that as we are speaking, the whole world is in a race to converge on the hydrogen. Now, just to give you 1 or 2 examples, European Union Commission declared their hydrogen strategy in the year 2020 as a part of their European Green Deal. And as we are speaking now, starting 13th February of this year till 19th February, United Kingdom is celebrating a hydrogen week. And perhaps this webinar of ours very much and well fittingly kind of coinciding with the Hydrogen Week celebration that is happening in United Kingdom. With this, I give the audio back to Manju. Thank you, Manju. Over to Manju.
Thank you, sir. And before we proceed to Dr. Tewari, we would just like to inform you about our new course which we have launched. So, we have just launched our advanced certification course in hydrogen technology application and its economics. This has been already started from 10th of February and would like to inform that is totally upgraded course till today. And again, there are 4 sessions in this course and we can just feel Introduction to Hydrogen, Characteristics and Fuel Cell Technology is session 1. This has been updated till today. Application, hydrogen plants, business opportunities. Again, there are so many case studies which we have included till today. Hydrogen storage, transportation and hydrogen economy. Again, we have included so many case studies updated till today. And value policy, regulation, project work, etc. That is in session 4 and it has been also updated till today. As you people know who have done the course already and the people who want to join the course, the program has 12 modules with sessions in the form of question and one has to appear for a viva, one project work, and it is required that 60% minimum passing marks for overall assessment to qualify for successful certification. The other programs are our 40 days mastering in blue hydrogen and the 15 days elementary program, Introduction to Hydrogen as a Future Fuel. And these 2 programs are also under upgradation and blue hydrogen program will be starting from 1st of March. We would just like to inform all the programs are online. Participation from around the world can do the program at their own pace in all time zones. The program is delivered through LMS and enrolled participants allotted a mentor for technical discussion questions they might have. And who is this program for? Basically, the program is suitable for all professionals working in the hydrogen industry or their organization is diversifying into hydrogen industry. Professional interested to know about hydrogen technology, production and its economics. I would just like to inform what is the current fee at the moment. That is for 101 days advanced certification program, it is 8,999 inclusive of GST or US dollar 130. For 40 days mastering blue hydrogen, it is 6,000 or US dollar 120. For 15 days, it is 1,999, and we are offering 10% discount to all women professionals. What we are doing, we are revising our blue hydrogen program. So all those who are registering before 25th of February, we are providing 20% discount to blue hydrogen program registrants, which is starting from 1st of March. There are a few important organizations which who have nominated their candidates, and all the candidates who have signed in and joined the course. There are certain PSUs and private organizations or MNC. You can contact us for registering on mobile numbers, WhatsApp, or you can call on us. Thank you so much. Now I will just request Dr. Tewari to start his presentation, please.
Thank you. Thank you, Madam Anju, for giving the overview of the program. Respected Dr. Patra, the Program Director of IESD, Madam Manju Sinha, all dear participants who are connected to this and given an opportunity to connect and interact with you all. Respected ladies and gentlemen, I welcome you all to the present topic of hydrogen spiked natural gas. Dr. Patra has already deliberated about what is the importance of the hydrogen and why we are going for hydrogen at all. Kindly bring it to the presentation mode. That's good. So first, actually, we talk of hydrogen because in the country, the formal announcement of the hydrogen was last year during the Independence Day of 2021. The PM has announced, like, if you see, the work has become much earlier than that. Hydrogen is not a new thing in the industry or in the its invention was done more than 200 years ago. And so for the oil and gas industry is concerned, hydrogen was used for the last few decades. Basically, it is used in the refineries for fuel upgradation, fuel quality, and the impurity removals like sulfur dioxide, sulfur removal, as well as the fuel upgradation also from higher end to the lower. This thing. And additionally, you all know that ammonia production is definitely centered about the hydrogen. So definitely hydrogen was used in the industry. Later on, when the environmental challenges started coming towards the world, so again, a thought process has gone whether how we can decarbonize the sector and how we can use the hydrogen is available in abundance in the form of the water and its derivative and all. So definitely there are certain processes and other things we can think of where we can possibly include and maximize the use of hydrogen. Once you produce energy, any energy or energy carrier, definitely you need to transport. Dr. Patra has discussed about the conventional mode of transportation. And in addition to that, what could be the innovative mode of transportation? Because ultimately, once you produce anything, it has to go to the end consumer through a system. So next slide, please. Manju, can you go to the next slide? In this brief talk we are going to have with you, interactive talk, we will be talking about primarily about the Indian energy sector. That is what is our decarbonization challenges, what is the role of natural gas in that. Then we'll be talking about the hydrogen ecosystem and its perspective in Indian system, as well as what is the world over. Hydrogen blending in natural gas, why we want to go for the blending at all, and what are the opportunities and challenges associated with that. I'll be focusing on the engineering challenges. Then what are the pilot projects, whether study observation, whether any code and standard have been developed or in the developing stage. And then we talk about the advantage and limitations. Then emergence and horizon also, what is going to be there. So, Madam Manju, I think you can capture the question, and because at the end we will be responding the questions to that. Now, let us first understand the primary energy mix of the country. you are not seeing the coal around you, but the electricity is coming to you is mostly generated through the coal only. So coal continues to be the major component of a primary energy mix of the country. Of course, in the coal, certain forest fuel and other things are also there, which becomes a part of the energy mix. And then, of course, followed by the oil and gas, particularly oil, liquid petroleum. Then gas is there in the system. Then, of course, we have a renewable hydro and nuclear power also. Presently, gas is having a less carbon component compared to the other liquid fuels like diesel, petrol, and others. So definitely the focus is that increase the primary energy consumption of the gas from presently, which is about, to be precise, 6.7% of the primary mix, to make it 15% by end of 2030. Accordingly, this is a mammoth task. As of now, be petroleum product for producing the petroleum product, we are importing about 80, so about 85% of the crude. So for the gas is concerned, still we are not sufficient in that. Year to year, some minor changes takes place, but it is ranging between 53 to 55% natural gas in the form of LNG, that is liquefied natural gas we are importing. Even a derivative like LPG, because after the Ujjwala Yojana, effort for the decarbonization to the rural sector for cooking purpose, the LPG consumption in the country has tremendously increased, and we import about 50% of the LPG too. And similarly, we have set up the distribution setup of the, and are also expanding the distribution setup of LPG too. Accordingly, we are importing in the particularly gas, we are importing in the liquid form, that is the LNG form, liquefied natural gas, which is around minus 170 degrees centigrade. So definitely we are having at present 6 to 7 coastal area operational terminal where we are having a capacity of receiving the liquid gas and regasifying and sending to this thing. Another 3 to 4 are under expansion, because the country has a mark of, if you want to reach 15%, definitely first of all you should have a infrastructure for handling, infrastructure for distribution, infrastructure for reaching to the consumer. Accordingly, the one small table is given which indicates that from 45 million ton of the consumption of LNG, what we are doing is as on today, we are likely to go up to the 100 million ton within a period of less than 20 years. So definitely huge growth rate is there. It is not an easy to reach 15% target. And you'll be surprised to know that within the 15% target, the energy mix in the different provinces of the country was different. Gujarat was above national average and to the extent of more than 20%. But the other states were deficient, particularly the northeast states were very, very low, almost negligible. So government is first focusing the infrastructure development uniformly towards the entire country, including the difficult to reach terrain like northeast. Advantage of the natural gas, you already are aware of that. I'm just for summarizing again, I would like to say it is a 45 oil too, and it has per power, if you generate the power, the per kilowatt power generation, 25% less emission than coal and 65% less emission, 25% less emission than oil and 65% less emission than coal. So you can understand that compared to the basket of the fuels available in the country, the natural gas supposed to be a better alternative for decarbonization point of view. And system is matured because first, if you remember, some of the my senior colleague Dr. Patra and others are connected, and some industry veterans are also connected. So you remember that first HBJ, Haldia Bijapur pipeline, we completed. Natural gas pipeline, we completed somewhere in 1988. So nearly 35 years have happened that the system has become little mature of natural gas handling and distribution in the country. Next slide, please. India is aiming the decarbonization, little bit of a decarbonization. Then I go to the straight with the topic. The decarbonization, we have taken an attempt because decarbonization is also helping in one way of import substitution, also provided you are able to produce domestically. So one is Satat, under biofuel we are creating, that is a sustainable alternative for development of the alternate transport fuel. Another is areas of high focus on the renewable energy because we want to produce the hydrogen using the renewable energy as a green hydrogen. Energy efficiency, existing system efficiency is our poor and we have to eliminate and increase the system. Just for a diesel engine conventionally, we have about 40% thermal energy or something like that. If we can improve that, definitely utilization of the per unit of the fuel will be high. Similarly, gas increasing share I talked about. We plan to go by 15% from 6%. Electrification, that we are going for EVs and charging station and country which about you can understand the expansion in that area also because country which has started about 1.5 years back, first electricity charging station among the retail outlet of the petroleum product about 1.5 years back, and today country is having close to 5,000 charging station in the retail outlet. So definitely that indicates the pace of that. Coming to the ethanol blending. So ethanol blending was another initiative because the country is consuming ethanol blending is done in MS, that is we commonly call it petrol. Country is consuming about 30 million ton, 300 lakhs ton of the petrol every year. And if you are country has already substituted about percentage of the petrol that is methanol blending up to the extent of 10%, that is country has already achieved, and pathway forward has been announced for the blending up to 20% with effect from the 1st April this year. So similarly, these will be the not also partly going for the import substitution. And Manju, can you please address this? All the questions should be coming and it is popping up every time, and so that we will be addressing in the end. And the hydrogen infrastructure is one of the aspect of that. Now coming to the hydrogen supply chain. Traditionally, the hydrogen has been generated in the, as we talked about, for production of the ammonia or cleaning or upgrading the fuel using either natural gas or naphtha. And normally, if you are not capturing the carbon dioxide associated with that, then it's definitely hydrogen, and which was within the use of industry. Dr. Patra has very well described about that. If you have to consume the energy generated locally, possibly you don't require a much larger transmission system. So the refineries were producing the hydrogen and they were consuming within their hydrogen desulfurization system and other things. So there was a not big transportation was involved. Similarly, in case of ammonia, we are locally developing, in the fertilizer industry was locally developing the hydrogen and going for a production of hydrogen and for a now country has already started and gearing up for the use of the hydrogen throughout the distribution system of the natural gas pipeline system, be it is a transmission pipeline system or sub-transmission pipeline system or a distribution system. Natural gas is transported from LNG location where we are producing natural gas. We are producing about 45% of that. From that location, we are carrying out certain cleaning aspect of that, modification in that, and then we are transporting to the pipeline system, or we are importing from LNG terminal and transporting. So the aim is to transport through the steel pipeline to cities, and then we have a low pressure system for distribution among houses, distribution for in the form of a CNG to retail outlet for filling your vehicles, and then the commercial establishment are directly getting at the required pressure the gas. Next, ma'am. Next slide, if you can make it. So aspects are covered like production, green hydrogen. Green hydrogen means hydrogen we are producing using wind, solar, or maybe the hydropower. Focus is more on wind and solar power. Or biomass or bio waste. Definitely they also contribute, but the quantum is definitely less. Gray and blue hydrogen we produce using natural gas, using oil, that is naphtha and all, and of the coal too also we have a coal gasification system also in country that is taking place parallelly. The process of the green hydrogen require the electrolysis, that is splitting the water in the form of a hydrogen and hydrogen as well as the oxygen. Oxygen can be utilized for the medical purposes, can be stored separately or can be sent to the atmosphere. And for the gray and blue hydrogen, that is a very common route is steam reforming route, where the reaction of the hydrogen with the help of a steam at high temperature is carried out and a syngas is formed, and that syngas is later converted for the production of hydrogen and all. And so hydrogen you get in the form as a system of storage and transportation. Either you can do in the form of the gas itself, either through the pipeline system or a high pressure temperature is very, very low, that is -253, so that is definitely the cost is very high. Then metal hydrate, certain reactions with you can solid materials and you can store the hydrogen in the metal hydrate form, and that can be revived and removed whenever needed. And of course, the derivative form like ammonia, you can carry the ammonia. Ammonia is nothing but NH3, that with the one nitrogen molecule, three hydrogen molecule, and conveniently you can recover the hydrogen whenever you want. Regarding the application, definitely transport, you are already aware. That's why we are talking of this system through natural gas distribution system. Refining and chemical, this has been age-old system. It's not a new thing. Power generation yet to take place on a commercial scale. And residential and commercial heating, definitely once the part of the natural gas distribution system, definitely it is end use is residential heating and commercial. And of course, urea production, petrochemical production, glass production, and eventually countries targeting, whether the world over is targeting for hard to abate sector like steel, cement, aviation, and shipping, which are producing a lot of carbon dioxide emission. Whether this can be progressively and systematically can be converted to the hydrogen, because the end product among the entire fuel cycle, all the product remove on when burning or when combustion takes place, they remove they produce carbon dioxide. It is the only hydrogen which produces the water vapor. Coming to the transportation side of that, you can have a pressurized road tankers in the liquid form or in the gas form. You can transport to them. Definitely the pressure is very high compared to the normal pressure of transporting of nitrogen and hydrogen in the pressurized cylinder. You can have a liquid form also for transportation. Recently, about a year back rather, a transportation from Japan, this Austria, has taken place. I mean, a cylinder of a tanker of a liquid hydrogen. So it's not uncommon. Probably, progressively, it will become more common. Storage can be above ground and can be underground. I mean, a large scale storage, the some of the thinking is going on the cavern storage too. There is salt and rock cavern in addition to the aquifers. Pipelines, dedicated pipelines, or can be there, as Patra was telling, Dr. Patra was telling, or hydrogen blending in the natural gas pipeline. Dedicated pipelines, you have to create entire infrastructure of your own. It will be time consuming, investment will be high. And if you are blending partly, you are getting a state where you are getting a big already built infrastructure. That is the advantage to you. Next. Why blending? First, I already discussed that infrastructures require time, effort, investment. That first you are minimizing. Research studies and pilot studies indicated that up to 15-20%, 15 to 20% value requires at least no modification or a very, very small modification, which is practically for the end user, which can be done at a low cost, allowing large-scale energy transport from production site to the end user. This is a major challenge in case of any energy form, be it diesel, petrol, or gas. Presently, 50% project and industrial pilot projects which are going on at present have given a very positive indication of minimum effect or no effect on that. And it is a matured natural gas. I said that it is in the fourth decade of the distribution in India. So even in Indian scenario, which adopted the natural gas much later in late 80s only, but still the system is now matured. We have a well-developed risk assessment structure, maintenance and safety protocol, because hydrocarbon handling through the pipeline system or any system requires a effective protocol of safety, and definitely we are aware of that, and we are making effort that there should be a zero accident. And whatever, if you see the accident rate of the pipelines is much less compared to the road and other accidents. Import substitution, it will be a step towards the Atmanirbhar Bharat, because India has been traditionally the importer of energy, be it crude oil, be it gas, except the coal. Somehow we are better in coal, but not in the quality of the coal. So coal also we are importing at times for the better quality. We are having a high reserve, but slightly lower quality coal. So definitely we are importing the coal. So this purpose will be there if as a part of the import substitution. Next slide, ma'am. Make the slide for next slide. Yes. So what is actually we are talking of? Hydrogen is basically natural gas is consisting of methane, ethane, propane, and so many other things. But the maximum 90% plus component is methane, which is a colorless, odorless, and non-corrosive and tasteless. And definitely component of the H2S, nitrogen, and other things are impurities of much lesser. If you talk of LNG gas, practically you are having a zero component of any sulfur. Domestic produced gas, we try to remove the sulfur beforehand, mercury, sulfur, and other component, we try to remove the beforehand. So it becomes much, emission wise, it is having a less problem compared to the other liquid fuels. Hydrogen, you know already, it is a colorless, non-toxic, it is lighter than natural gas, and much lighter than air, and higher flammability range is much higher, that is 5 to 75% something. And then common blend becomes high flammable, that we have to handle. Compared to the natural gas, it becomes high flammable. Laminar combustion velocity is high, ignition energy high, higher combustion temperature it may produce. So these are the components engineering wise we are supposed to be handling that. That's why the percentage is limited where we are going to use and what is going to be the end application. Next slide. Next slide, ma'am. Engineering challenges. Hydrogen blending density is lower than methane. So any leakage from the same leak size, the volume flow will be high because it is lighter than that. Viscosity reduces with the hydrogen blending non-linearly when the hydrogen concentration increases. So we are talking of 5 to 15 or 20%. It is a manageable within that. Molecular mass reduces the side branch flow, Benzi forces. Why? Actually, it is a lighter. Once we inject that, there is a chance that it has a stratification in the pipeline, has a tendency of getting topped at the upper layer of the pipeline. That's why it is injected normally from the lower side at a certain angle, so that the dispersion, as per the dispersion model, it becomes almost stratification is avoided. Heating value of the blend increases, and more energy requirement of blend, that is more energy for compression, because in the CNG and all, when we are going for that, you go for a vehicle of 250 bar filling pressure or nitrogen, I mean pressure of the CNG. So definitely the energy little more is required in that, because the lighter gas if you are compressing it, you require more energy in that. Certain safety issue, because the higher temperature, higher explosion, lighter. So risk assessment has to be accordingly geared up. India is used to of having safety structure well lined as per the regulators requirement and the ERDMPs and all those things. Definitely we can address that changes whatever is required to be done for the perpetual introduction of a hydrogen. Greenhouse effect, it reduces the SOx level, particulate matter, and definitely NOx level, it increases, but certain beyond a certain level only, not up to the 30-40%. The NOx level has no effect on that. Extraction of hydrogen in downstream, if you want to separate, because it's a gravity and density wise different, so you can have a membrane system to separate. If you want to, for end use, you have some specific application for hydrogen turbine or something like that, possibly you can separate it also. Industry in the studies indicated 5 to 15% can easily accommodate. Next slide, ma'am. In the steel pipeline, I'll be touching about other aspect too. Most prominent problem we have see that pipe material degradation, that is the embrittlement of highest tensile strength. It reduces the ductility and affect the mechanical properties. I'll be discussing little bit more in the next slides. Switching engine burner from methane hydrogen mix to with the minor modification may be required in burner. Definitely in SI engine as such no modification required, because a lot of I mean, testing has already been completed both by Indian Oil and elsewhere in the world, and it is okay. Suitable for large gas turbine because the higher temperature and the larger enthalpy drop will produce higher output. In the process, the higher temperature for the steam also if you are burning hydrogen, and the burner efficiency up to higher burner efficiency you get up to 25%, and of course more than 25% some flashback and other things takes place, so that is not right now done. And one good study, because the embrittlement leads to the crack formation in the pipeline. That is a major challenge for any pipeline operator. One simulation study as well as the cyclic loading based on the cyclic loading pattern, the study was carried out in the lab for particularly a pipeline of X42 grade, because higher grade pipelines have a more susceptible to cracking. And it was done that if we less than 40% crack was already created actually in the pipeline, to see that what's going to be the hydrogen environment effect on this thing. And simulation study and fatigue testing analysis indicated that even 100 years, the crack will not be propagating up to 75%, over 75% of depth, which is already 40%. That means a pipeline is considered failed if it is 80% metal loss, so crack has taken place. So that indicates, though the tendency of the hydrogen is there for the crack development, but definitely the crack propagation speed and other things are not so high. Next slide. Kunch distance of hydrogen is smaller, so heat loss to the chamber wall would be little increased by addition of hydrogen into the natural gas. Energy density is almost 9 times lower, so blending reduces the effective energy per unit volume, and definitely that possibly requires the higher compression too. And one advantage in case of a submarine line, of course, we are talking of only the natural city gas distribution pipeline, but in case of a subsea pipeline, natural gas hydrogen blending can avoid the hydrate formation. And so hydrate formation in any natural gas pipeline is a major risk. So if it reduces the risk rather. And laminar burning speed of the hydrogen is nearly 8 times higher than that of natural gas. So addition of a hydrogen can increase the burning velocity and brings advantage to the shorter combustion duration and constant volume combustion duration. You get little more and improved thermal efficiency of the engine you get. Next slide, ma'am. Here I am trying to explain you what is the so-called the brittlement, hydrogen brittlement. Let me tell you, first of all, I have spent about 40 years in oil and gas pipeline industry. So may I submit that hydrogen is not a new thing to the otherwise pipeline industry. Not a hydrogen is a form of gas, because crude oil is having H2S. We get a hydrogen from that also. And cathodic protection system in the oil and gas underground pipeline that also generates the hydrogen. So industry is little aware of that. I'm explaining because if you see the scanning picture of any metal or something like that, so hydrogen, what actually tries to do, it tries to go to the grain boundaries, inclusion, voids and dislocation, because metal appears to be very plain from the top. But if you see the microscopic, there are certain hills and valleys, certain irregularities in the metal. The hydrogen tries to, smaller molecule of hydrogen tries to get settled in that hydrogen atom there. And precisely that depends on what is the partial pressure of hydrogen, what is the total overall pressure of hydrogen, and what is the concentration of the hydrogen, and what is the temperature of hydrogen. That basically decides whether the embrittlement, that is a passing through the lattice of metal, the hydrogen atom will take place or not take place. So accordingly, the controls are exercised in the pipeline. Next slide, ma'am. So we conclude is brittlement aspect, that strength of material and residual stress, because when the forming or welding takes place, certain stresses develop in the metal. So it depends on the strength of material, as what is the yield stress of the material or ultimate tensile strength of the material, but same time what is the residual stress in the system, pressure, temperature and exposure time, as we talked about, strain rate and surface condition of metal, which is a smooth or it's having some irregularities in that, and concentration or amount of hydrogen you are exposing to the metal. Certain metal coatings are there which prohibits the hydrogen going into the metal like this, and microstructure of the material, it is a ferrite, bainite or other structure. Depending on the type of structure, the penetration of the hydrogen increases or decreases. And certain solution make the reaction with the metals like acidic solution or something like that. So that I prefer to avoid. And heat treatment of material. Characteristic of nitrogen, particularly the nitriding, improves the, I mean, the embrittlement properties will be improved. There won't be more embrittlement if suppose you are using a nitriding as a process of heat treatment. So we summarize the problems here, that material toughness, ductility, elastomer effect, because we are trying to distribute through the pipeline system, which has a PE pipe too, leakage permeation, effect on the pipes and the meters, and of course, end use burners and others, what effect you are having. Next slide, ma'am. Ma'am, next slide. One of these studies, of course, so many other studies will be presenting also, but that's one major study, the Gas Technological Institute of the USA, they have carried out the life cycle assessment of the hydrogen blending, and their ultimate and industry is normally guided by their observation. They said that the safety is acceptable up to 15% blend. Leakage assessment, it is like to increase. So definitely you should be prepared for the better leakage management system, better sensors to find out the leakage if it is happening. Industry, pipeline industry and others, they are already aware of this. And they also indicated one very vital point, that lower grade, that is API grade pipe you use for the steel pipe in the industry for transportation, up to X40, X46, and even X52 is suitable. Sometimes we have X70, we have gone for that, but higher grade like X80, X100, even X70 to the extent to be possible to avoid it. They concluded up to 50% in this lower grade. Lower grade means low tensile strength steel. The 50% even may not cause the much failure, and there will be appreciable, almost no effect on the PE line also and the gas metering. That the Premier Institute gives findings, tells that it gives a little confidence among the engineering fraternity. Integrity was as such not much affecting the distribution pipeline. However, minor modifications are required for integrity management, like frequent inspection, type of inspection, and other things. Like in our crude oil, S2S bearing crude oil pipeline, we go for a periodically UT crack detection inspection, so that we find about any cracks in the system or not. Something kind of an integrity management would be required. And of course, end use, you can go for, if you are using as a hydrogen, you can separate using a specialized membrane, or some modification may be required, depending upon what type of use you are going. And impact of environment, definitely it is a less harmful, less emission, less effect on the environment. Next. Regarding the PE pipe, because the low pressure distribution, we go for a combination of a steel pipe as well as a low, polythene pipe. And study also indicated that as such, there is no effect for a, they have taken a study for 1,000 hours or something like that for various pressures, various institute, and as such, there is no problem was found. And they indicated that it is safe and efficient distribution of the natural gas can be done along with the hydrogen mix, can be done with the PE pipeline system too, which is operating in a lower pressure. For example, in your houses, it is coming in millibars. Some millibars only you are getting. And for a distribution industry or something like that, they are getting around 4 by 5 bar, whatever is required. And particularly for CNG, you are getting at a low pressure, then you are having a compressor, which is compressing to 250 or 300 bar and putting it to the vehicle. So normally distribution system is at a lower pressure, where these pipelines are also suitable in addition to the steel pipeline. Next one. So research finding of the hydrogen blending in the natural gas was carried out almost world over. US indicates that 5 to 15% volume is possible in there, and given clearance for their USA grid. Canadian research, little more conservative in that, and the research council, that is a laboratory, they can undertaken the test, and they indicate 1 to 5%. Australian report says clearly up to 10%, no problem. And of course, significant impact on the quality, material risk, and other things they have tested, not much. Netherlands project says blending up to 10%, and further they are carrying out some research on that. Denmark concluded 15%, and UK concluded up to 20% blend, hydrogen blend. Absolutely no issue on that. You can go with that. Next. Advantage, we reduce the import bill. First of all, we discussed. existing capacity utilization of gas infrastructure. Because if you see the most of the gas pipelines are designed for future use. So day one, they are not supposed to be there saturating the capacity. So most of the gas pipelines, you are having some cushion for the future use, and that possibly can be utilized and filled using the hydrogen. Reduce, even some of the trunk pipelines are having 50% cushion on that, something like that, that can be possibly utilized. And city gas distribution, the area itself is coming up, network is coming up, and wide infrastructure, 96% of the geographical area and 86% of the population will be covered with the city gas distribution. So that much volume you are having for distribution setup. Reduced emission, we talked about. India has a potential of becoming the hub for green energy. Suppose, as we are trying after the COVID, that we should be the manufacturing hub. We are manufacturing the aircraft, we are manufacturing defense equipment. Similarly, India wants to become the green energy hub so that we can be importing instead of a import dependent economy. We should be exporting the green hydrogen to the other places. We'll be able to meet the climate target for, we have a SDG goal. We have to meet the climate target for that, particularly the clean energy target and climatic condition. And this is the way forward in this. And Bureau of Indian Standards has also developed a specification 17314 for hydrogen enriched compressed gas, because the study was already conducted by 50 buses in the Delhi, and it was found to be okay, and then the codification was done. Next. Coming to the manufacturing side of that, you know that electrolyzers are basically of three types: alkaline, polymer, and solid oxide. Alkaline is a very common and very old used system for electrolyzing, and efficiency range and the life is given. Solid oxide electrolyzer is a little costly, and it operates at high temperature. Difference between alkaline, PM, and solid state is alkaline and PM, they operate between 100 to 200 degrees centigrade. Solid oxide operate more than 600 to 1000 degrees centigrade. So that's why the electrolyzer life is less and cost is also a little high, but the research is going on so that it should go down, the cost should come down. Methane reforming, you know that if we are having both carbon capture system, then possibly methane reforming, you can produce the blue hydrogen. Autothermal reforming and methane reforming. Similarly, the cost varies with the whether you have a prior system or you are going to install the system now. And you can, if you are utilize that carbon capture, definitely blue hydrogen will be a great help to you, because the green hydrogen initially the cost is very high to the extent of nearly $3.5 to $5 per kg, and eventually it will be reduced and will become more competitive. That is the prediction. Next. India budget has given many initiatives for the green initiative in the budget. Solar power allocation has gone up. Refineries for the net zero emission, 35,000 crore for energy transition. Battery storage, VGF for battery storage, 13 gigawatt of the renewable energy from Ladakh, a remote place. And green hydrogen mission is also close to 20,000 crore have been allotted. And India has been made a production target has been given for 5 MMT of a hydrogen production by 2030. World over, as on today, we are producing 94 MMT of the green hydrogen. We expect by 2030, we'll be producing 115 MMT of the green hydrogen world over. Out of that, India itself is targeting the 5 MMT target. Allocation has also been increased for the refineries for going for a cleaner fuel. Green fuel, the terminology like green fuel, green energy, green farming, green mobility, green building, green equipment has been made for policy support of the government. And first time, because none of the petroleum product comes under the GST, the biogas and CBG has brought under the GST in this budget. Next. Coming to the Indian scenario, GAIL has already started blending in Avantika Gas Indore with 2%, and it was successful. 18% blend Indian Oil Corporation, DTC, and of course Delhi Pollution Board. Together, they carried out the 50 buses running, and results are very encouraging. NTPC is started with the help of a Gujarat Gas in Surat township for blending. DNV is taking a technical study for PIL. PIL is a Pipeline Infrastructure Limited, having a major share of the Reliance pipeline. They have already undertaken the study for the trunk pipeline, whether they can put the hydrogen in that. Interconnecting line, spur line. EIL is taking EIL being a main consultant is undertaking technical study for suitability for entire industry in the petroleum sector. Islam Italy has been recently had by Indian Oil Corporation for technical study. So these studies and other things are already happening in the India. Now, these are some of the world project which have given a good result, like UK, France, EU, Australia, Canada, USA. So everywhere the ranges are changing. India wants to concentrate up to 20% blend initially, and results are favorable. Next slide, ma'am. As I talked about the Indian scenario, hydrogen blending has already taken place and we are comfortable in that. And NTPC blending also, the initially preliminary results are giving a good indication, and technical studies are also going on with IOC, GAIL, PIL. Even All India has also called for a technical study in that. And apart from the private sector, they are also undertaking their study in their domain for the blending of hydrogen in natural gas system. Next. Next slide, ma'am. Key challenges we discussed about, we are summarizing the key challenges: increased combustion temperature, technical challenges, flame speed of the gas blend may require design modification in IC engine. Practically in IC engine up to certain blend we have tested, it's not required. Burner, some modification will be required if you are going to 20-25%. Lower mass flow and energy transport requires additional compression, we talked about. Increased risk of leakage, definitely the sensors and other thing which we are having a hydrocarbon detection sensor or gas detection sensor, we have to convert into a hydrogen detection system so that we should be able to understand that leakage system or identify the leakage and attack on that. Embrittlement, we talked about in details like that, certain up to a certain pressure, certain elasticity of the steel, that is a X42 or X46 up to even X52. As such, we are not having much problem if you are operating X70, X80 and X100. Study is yet to be carried out and anticipated some problem of, because pipelines are designed little bit ductile. The hydrogen penetration to the lattice increases the brittleness of the pipeline. We call it term like toughness of the steel. The toughness, in fact, I tend to reduce. The toughness is the property which prevents the crack propagation in the steel. So that property, if it is affecting, so crack becomes faster than that. Next. Pathway India, as you already know, we discussed about 5 million pathway, over 8 lakh crore in total investment, creation of a huge jobs, abatement. India is the third largest carbon dioxide emitter in the world after US and China. We emit about 2.6 gigaton per annum, a huge number. A small sum of 50 million metric ton of annual greenhouse emission reduction is targeted. Large scale investment for the renewable energy. As of today, country is having total to the extent of nearly 130 gigawatt of renewable energy, and country wants to go for a 500 gigawatt of renewable energy by 2030. Incentive has been given for the green production and purchase obligation, because the electrolyzer cost is expected to come down by 70% to the end of 2030. That is, the competition is taking place. India has also started manufacturing. I mean, the manufacturing base is set up, and net zero commitment of the carbon emission, carbon dioxide emission, the country is going for that, and we have to be geared for that on this. Next slide. So hydrogen mission pathways are very clear. Demand creation, because the purchase obligation and other things will come. Utilization and export of the green hydrogen. If you are able to produce sufficient quantity, we'll prefer to export, like your medicine export, aircraft export, and defense equipment export we are targeting. Even under the strategic intervention, two distinct, encouraging the domestic manufacturers of electrolyzer. Already some companies have moved in, others are at the threshold and are becoming. Incentivizing the production of green hydrogen by production link incentive. Support pilot project in emerging and use sector and production. Identification of a large scale hubs and utilization of a region for a green hubs of hydrogen, like we are having a textile hub, we are having a petrochemical hub or something like that. So we are targeting the hydrogen hubs in the country. Next. So Government of India has also announced that a great motor vehicle act amendment has taken place for the hydrogen CNG mixing, blending, codification has been done. It was worked out that emission reduction of CO is down by 70%, 5% fuel saving. It is the first step towards this thing, and definitely some auto manufacturers like Maruti and Toyota started working on SCNG engine, long-term effect and what modification they can carry out. This all positive side, possibly you'll be getting a ready engine for SCNG in the market. Next. We conclude that hydrogen blend up to 15-20% are suitable for transportation through the existing natural gas distribution network. No major modification as such is required for CI and SI, both compressed ignition, that's the diesel engine, and spark ignition like petrol engine. No major modification needed for burner and heater. Blend compatibility with PE pipe, walls, elastomers, because your metering system has so many seals and other things of elastomers. Fuel saving up to 5% with improving the efficiency. Support decarbonization initiative. Import substitution, Atmanirbhar Bharat, towards the greening natural gas, and a step towards India becoming the smart hub for the hydrogen export. So for the codes and other things are concerned, I would like to tell that BS code has already been developed for the gas transportation code in the country. OSD 226 is under revision, and body has already been formed. Couple of months later, they will be possibly publishing the revised code for the hydrogen CNG mixture. Additionally, technical studies undertaken by EIL and other public PSUs, they will be providing input, and the code will be separately developed. ASME B31.12 2019 version of hydrogen piping little bit talks about the compatibility of hydrogen, so that the details hydrogen pipe codes are already there in the existence. Next. That slide could be the last slide, ma'am. So we have a pathway for hydrogen. Current level we are using for the refinery process, methanol production, ammonia production, hydrogen fuel car, some numbers have already come, and biofuel upgradation, viscosity of biofuel and other things are reduced. Next 3 to 7 years, we are targeting steel sector, which is a mega sector, coal guzzler or something like that, cement industry, glass industry, downstream other chemical industry, electronic sector, heavy transport vehicles, public transport, and hydrogen train. Even railway has ordered the concept of hydrogen train, and maybe the couple of years later, we see the hydrogen train really running. Some of the countries, it is already operational, not a large scale, but the pilot level it is operational. Small vessels and ferries, we expect that within 5 to 7 years, we'll be able to do that, either directly as a hydrogen or in an ammonia route, or building, heating, cooking. Definitely is a part of a setup of your distribution. Definitely to be achieving the same. And other difficult sectors, because the cost is also important factor. Power sector will be touching by 2030, beyond 2030. Large shipping, because shipping contributes about 3% of the total emission, and not only the carbon dioxide emission, but SOx and NOx too. So the shipping sector has been left. As you know, the quality of fuel has been improved for the surface sector India, like BS6 norms or something like that, where from within 20 years, from 10,000 ppm sulfur, we reduced to 10 ppm sulfur in diesel, and 2,000 ppm sulfur in petrol, we reduced to 10 ppm. So similar kind of things are required in the shipping and aviation. After all, as per the MARPOL guidelines from 2020 January, we reduced the sulfur content in the shipping. Like a lot more needs to be done. Aviation sector, it's a very difficult sector. Definitely will be going for a hydrogen powered fuel. Some study has already been started. It could be two routes. Synthetic kerosene they can generate either using the hydrogen, or they can go for a hydrogen directly. And liquid hydrogen and other things was not a, it was an old phenomena using the NASA from 70s. Possibly that can be upgraded for the aviation sector. Next slide, it is a reference, ma'am. For developing this aspect, we have carried out the reference. Next, last slide now. Thank you very much for your attention. I'm ready for question.
Yes, sir, there are many questions and we will be taking one by one. Basically, a lot of questions you have already answered with your presentation. So I'll just ask you the first question. That is, please elaborate us about in which format hydrogen transportation is economical. By metal hydrates absorption, mixing with natural gas, blending, ammonia transportation, and then conversion of ammonia into methane. That is question from Viresh Tadole.
Most cost-effective route is the transportation to the existing pipeline, because you are not converting to the, you are remaining in the gas form and transporting in the gaseous form itself. No additional conversions are taking place in the first front end. So natural gas distribution is the cheapest option. Of course, all other sections like liquid making or making a compressed cylinder or making ammonia or hydrates is a costly option. Cheapest is the transportation through mixed blending in the natural gas.
So next question is from Rishabh Singh. What is the hazard related to use of hydrogen in terms of leak and emissions?
As you know, the industry is already facing the leakage and other things, and for that we are having a leak management system and leak control system. So hydrogen with a high ignition temperature and other things, if it is leaking, and it is almost very, very light. Hydrogen, if you considered air density as a 1, so hydrogen is 0.07 only. So it is much lighter, so it will be quickly diffusing in the atmosphere itself. As such, if it is allowed to leak, it will go. But the idea is not to allow the leak, so that the leak detection system will be little improved. We are already having a leak detection system in the natural gas distribution pipeline as well as the trunk pipeline. Little more based on the hydrogen sensitivity, like hydrogen sensors in critical locations like compressor and all, and distribution points are required, and that can be built in, that will detect the hydrogen leakage, and accordingly the correction can take place. As such, we don't anticipate, because both natural gas and hydrogen both have the hazardous fluids. We are already handling that.
Next question is from Anupam Sonkar. How to control local hydrogen concentration, temperature, and pressure?
How to control local, because you are mixing in a predetermined volume. So you are already knowing what is the, normally when the distribution pipeline takes place, distribution is a normal temperature. It's not a high pressure, high temperature. It's a low pressure, almost few bar pressure, and as well as the normal temperature, ambient temperature. We are not trying to increase the temperature. During the process of burning, you can have some temperature high on that. So little temperature high up to the extent of to 10% or even 15%, that has been permitted. In case of a burner, high temperature is going to produce in the industry, and you know what is the maximum set limit of the temperatures in that. You can control your set limit if you want to, or you can regulate the flow of hydrogen mix accordingly to maintain the temperature, as we do in case of any furnace or something like that. We regulate the flow of fuel to maintain the temperature. That kind of a thing is required. For example, Indian Oil recently, I mean couple of years back, started nano additized LPG. When the temperature goes high, temperature goes high means the cooking is faster on that. But we require a certain level only. We don't want that it should be too fast or something like that. So we have added accordingly a small quantity nanoparticles in the LPG, so that the temperature goes high, flame temperature goes high, the cooking is faster. Accordingly, we have to mix accordingly to our end requirement.
A question from Ansar Sayed. Water vapors also have global warming potential. What could be effect of huge amount of water vapors released into the environment?
Yes, definitely. If it is so, possibly, as we are having, what is happening? The tail end conversion system was already there in the existence in the automobiles. If you see that catalytic converter based tail conversion system, which was suppressing the NOx of the tailpipe, I mean the exhaust emission, something like that. If it is the problem is reaching to that extent, possibly some technology will be the water conversion will also come in the system.
Question from Tridib Hazarika. At present time, what is holding back the production of hydrogen in India? Is it infrastructure unavailability or consumer unavailability?
Both system, because the infrastructure required to be developed, as you said, that the product produced hydrogen, you can do that, but you require to set up putting a electrolyzer for hydrogen, or using the hydrogen through fuel route like natural gas or something like that. Then you require a carbon dioxide gas pipeline infrastructure for carbon capturing and utilization. So this is the major challenge. But only good thing I would like to add here, which was the last slide I indicated, the Niti Aayog has parallelly indicated a policy guideline and path forward for the carbon capture, utilization and storage system. The carbon can be captured and utilized in the empty gas fields, salt cavern and other things. So that policy of the government of India has already come. So they will be developing that. So progressively this infrastructure of the carbon capture will be developed, electrolyzer installation will be developed. Right now, we require a better quality of water. Even the today's news was there, the salt water, I mean the sea water was successfully, electrolysis was conducted for removing of, producing of hydrogen. So progressively the technologies are evolving. Right now, the infrastructure we need to create for hydrogen production, or if it is a gray hydrogen or blue hydrogen, we need to create an infrastructure for transportation of the crude carbon dioxide emitted or something like that. So progressively, these sectors have to evolve. Since we have already given a path forward, like high, the present cost of the green hydrogen is also very prohibitive, more than $3 per kg or something like that, $3.5 per kg. We expect it will go down to $1 per kg by 2030, but some of the industry experts say that it should be around $1.5 per kg, so that will be comparable with other things. So if we are able to achieve the scenario, though Reliance in a high green network of a green energy, when they set up, they indicated that with their setup, they'll be able to produce the green hydrogen up to the extent of $1 per kg. Possibly that takes place and will be successful in that. Presently, definitely the infrastructure has to parallelly evolve. Industries have been identified and they are encouraged to use, because the carbon emission everybody wants to minimize.
There is a question on our blue hydrogen program. I would like to, Dr. Patra can answer. In the blue hydrogen course, would you tell us CCUS or more discussion around the combustion management for SMR or both?
Blue hydrogen is primarily focused on CCUS. Here the premise is the gray will be converted to blue by using the CCUS technology. So the primary emphasis is on CCUS.
There is a question from Naveen Kumar. For solar dependence on China raw material and USA PV technology will impact green hydrogen targets of India, I think. Tewari sir can answer, sir.
Yeah, I missed the question. Kindly, please. Will you please repeat the question?
Yeah, sure. For solar dependence on China raw material and USA PV technology will impact green hydrogen targets in India?
It has substantially started developing their own PV technology. So dependence, of course, so you cannot say that it is totally eliminated, but substantial reduction in the dependence on US and China and the solar PV module has taken place over the period of time. That's why the cost of the solar has gone up. Even the solar energy cost has also gone up, because we could improvise. Let me tell you my example of my Indian Oil Corporation example. Way back in 2012, I commissioned a small 5 megawatt solar plant in Rajasthan. Cost was very high because we spent about close to 90 crore or something like that for 5 megawatt generation cost, and that too in a remote location where the land cost was not so high. And we got a revenue for that 12 rupees 57 paisa per kWh, per unit of electricity, 12 rupees 57 paisa. Now, because the cost of everything was very high, raw material cost was high and other things were high, we are not able to sell lesser than that. Government was also very keen to buy at 12 rupees 57 paisa. Now, the solar cost produced energy, electricity is available less than 3 rupees, around 250 to 3 rupees per unit or something like that, because the penetration of the technology within India has taken place over a period of time.
Next question is from Satish Ayanagar. And which are new natural gas pipeline and CGG network projects envisaged with green hydrogen blending up to 20%?
Actually, if you see the CGD network operator in the countries are close to 50, and CGD and trunk pipeline in the country, why we are thought of infrastructure using the gas, because the trunk pipeline in the country of natural gas, apart from the CGD, is about 21,000 kilometers. Another 25,000 kilometers are under construction. In CGD, progressively, Avantika gas become little premier because it was with the GAIL. Some players are PSUs like IOC, BPC, HPC, Oil India Limited, and others. But there are so many private players are also there, like Adani, Total, and all. So all are planning, but they are also planning from where they will be sourcing the hydrogen. So they have them already mapped some of the, even in Haryana, some of the city gas system, they want to go for a hydrogen blending. But progressively, they have not yet announced their formal program. And as Avantika was successful in 2%, they wanted to go up to 5%. So progressively, such scenario will be building in the country, depending upon the availability of hydrogen to them.
There are many questions from Mr. Satish. So what we can do, we will put it on website after answering from Dr. Tewari. So I'll take a few more questions because we are short of time. So question from Vinay Kumar Shukla, domestic use is possible or not? If yes, then how?
Domestic use of hydrogen?
Yeah.
Or blend?
Blended hydrogen.
Blended hydrogen, I indicated that you will be using in your car. You have tested in the buses in Delhi. You already using in the car, in a city gas system. When I talk to Avantika gas distribution system, this blending has already gone to houses. Blending has already gone to industry. Blending has gone to all the retail outlets in the form of a CNG. So the uses is already established. Market is already established. Only you have to create the infrastructure for that. So you start blending on that. And accordingly, I indicated the CGT has a three component. One is the industry directly feeding 4 bar, 6 bar, whatever is the requirement and the pressure. Another is the domestic consumption, which is few millibars only coming to a burner. Third is the CNG component with the vehicle filling and all those things, truck filling, bus filling, vehicle fillings and all those things, where we further increase the pressure up to 250 bar or 300 bar, because your cylinders in your cars are designed for 250 bar. So we increase the pressure so that in a small volume, you can store the larger volume. So it is already there. Market is already there, not a new concept. Only thing we have to propagate the use of hydrogen and progressively, as I talked to you about example of methanol. When methanol was not there, we are still consuming the petrol, which are consuming the petrol. Country is consuming the petrol to the extent of 30 million. Overall petroleum product country is consuming to the extent of 215 million metric ton per annum. Out of that, petrol we are consuming about 30 million metric ton per annum. When 10% ethanol we have successfully blended, we already achieved. None of the engine has problem, nothing like that. Manufacturers has no problem. We have achieved 10% blending, means to the extent of 3 million ton. 10% of 30 million ton. We have gone for the import substitution because the methanol we are producing in our own country. So similar kind of approach is required for the hydrogen also. A small blend we are targeting that is not going to affect your fleet of vehicle, CI or SI engine, as I submitted in my presentation.
This will be the last question which we are taking. Rest of the questions we will answer and put it on website. The recording of the video also will be on the website. So our last question is, can you provide the safety standards to be followed for domestic purpose, since hydrogen mixing will result in hydrogen reaching houses through PNG network, considering the wide explosive range?
Yes, very good. Certain modifications in the systems are initial. PNG-RB regulations, which are talking of ERDMP, Emergency Response and Disaster Management Plan, they are incorporating hydrogen aspect in that. As I submitted, that OISD, which is a nodal body who creates the code in the country, they are also revising the gas code in the country. and to include hydrogen, that is OSD 226, which consists of two parts. One is the trunk cross-country pipeline, and second part is the CGD network. They are also considering the safety aspect. Oil Industry Safety Directorate, as the name itself indicates, that deals with the safety. They are also revising 226 code for adding to this nitrogen. And additionally, as I have already submitted, BS code has already been introduced in the country, 17314, which indicates that the hydrogen blending to some extent is suitable for the vehicle, with absolutely no problem. For the domestic and other industry, the codes are under revision.
Thank you very much, sir, for such an informative session, and you answered many questions. Still, we have many questions, which we will be sending it to you, and you can just answer it, and we will put it on our website.
Thank
The
you so
recording
much.
will be available on website. So
Thank you.
all the candidates can visit our website and can see the video. Thank you, everybody.
Thanks,
you.
Dr. Tewari, and thanks all the participants. It was very exciting program. Thanks. Bye-bye.
Thanks a lot. Thanks a lot, Dr. Patra. Thanks, Manju, and all the participants.